Hi everyone, welcome back. Today we are going to see about the Ohm's law. So the terminology is current. The current is nothing but a current is just the rate of flow of charge. That is the rate of flow of electron through the conductor with respect to the time is nothing but current. And voltage is nothing but the voltage across the two points, two different point. The potential difference across two point is nothing but voltage. And the power is nothing but the rate at which work is done is transformed into the electrical power. That is the product of voltage and current is nothing but power. And the resistance which is used to oppose, which is opposing the flow of current in electrical circuits. And the inductance. Normally an inductor, it stores the electrical energy in the form of electromagnetic field. And the capacitance, it stores the energy in the form of electrostatic field. And this circuit, a circuit is the path that starts and stop at same place. That is, a circuit means a network, it contains at least one closed path is nothing but circuit. Okay. So what is the definition of Ohm's law? So an Ohm's law and potential difference is nothing but called voltage, pressure, potential, etc. So the voltage across a conductor is proportional to the current which is flowing through it. So during this time, the temperature, it should be constant. During the Ohm's law, the temperature should be constant. So according to the Ohm's law, the current which is flowing through the circuit is directly proportional to the applied voltage. So the current which is directly proportional to the applied voltage. So therefore, V is directly proportional to I. V is directly proportional to I. So while we are cancelling the proportional, we are multiplying the constant is K. That is nothing but here resistance R. So therefore, V is equal to IR. V is equal to IR. V is nothing but this supply voltage, the potential difference across the terminal, and I is nothing but the flow of electron in a circuit. And R is nothing but the proportional constant, that is nothing but resistance. So V is equal to IR, or R is equal to V by I, or I is equal to V by R. We can write anything. And these are the simple circuit with Ohm's law. So just we can see this here. So in the first circuit, the battery is 20 volt and the resistance is 4 ohm. So now we have to determine the current. So I is equal to V by R, voltage by resistance. 20 by 4 is equal to 5 amps. And you can go for the second diagram. So here we can know the value of resistance and the current. So we have to determine the voltage. So V is equal to IR. I value 1 and R value 12. So 1 into 12, 12 volt. And then third one, so we know the value of voltage and the current, but we don't know the resistance value. So R is equal to V by I. V is 6 volt and I is 3 amps. So V by I is nothing but 2 ohms. So with the help of this Ohm's law, we can able to determine the voltage, current and resistance of this circuit. Okay. So can you solve this? Here the voltage and the current is given. So we have to determine the resistance for the different voltage and different current rating in a circuit. And the power dissipation in resistance. The amount of power which is dissipated across the resistance, it may be calculated using any of the three formula. Okay, so it's based on the factors, that is P is equal to I square R. P is equal to I square R. So it is derived from power P is equal to V into I. We can use power P is equal to V into I. So instead of V, we can substitute V into I. So once again V into I. So it is nothing but P is equal to V is equal to I by R. So I by R is nothing but I square R. Otherwise V square by R. So with the help of any one formula, we can determine the voltage drop across the resistance. And this is the second assessment. Can you solve this problem? So here we have to determine the power which is dissipated across the resistance. Okay, so option in A, here the current is given, resistance is given for all the option for first option, and we have to determine the power. And in the second, current and resistance is given, so we have to determine the power. And third one, voltage and resistance is given, we have to determine the power. And fourth, voltage and resistance is given, we have to determine the power. Okay, and second question, how much power is dissipated by an 8 ohm load if the current in the load is 20 milliamps? So put your answer in the comment section. And the limitations of Ohm's law, so here it cannot be used for the unilateral element and non-linear element. It is applicable only for the linear element, and at the time and the temperature should be maintained as constant. And these are the references for this topic. Thank you.